with the National Council of Vocational Education and Training. Our promoting bodies are Automotive Component Manufacturer Association of India, Society of Indian Automobile Manufacturer, and Federation of Automotive Dealer Association. We are also supported by Government of India, by the Ministry of Heavy Industry, Ministry of Skill Development and Entrepreneurship, and Ministry of Road Transport and Highway. Our key roles divided into the 7 work. Our first role is standard. ASDC has standardized more than 130 job roles based on industry requirement. And we also provide training of trainers and assessors to ensure high quality delivery. ASDC focuses on building the capacity of trainers and assessors. This improves their training delivery skills and in turn enhances the overall quality of training and assessment in the sector. The third role of the ASDC is affiliation training partners. We affiliate training providers and centers, enabling them to commence NSQF aligned training. We also provide assessment and certification. Assessments are conducted by the ASDC certified assessors in alignment with the NSQF standard. Candidate receives government recognized certificate, adding credibility and acceptance to the training program. The fifth one is we also provide domestic and international placement. ASDC actively organizes placements drive to support the employment of the certified candidates. We also manage World Skill, Asia Skill, and India Skill competitions. Currently, we support 10 multiple skill at World Skill and India Skill level, and we are proud to announce that this year India has participated in Asia Skill also, which is scheduled in November in Taiwan. And the seventh last role is the project. We also work as an implementation body for the projects in CSR, government and non-government and other special initiatives, helping scale impact at the grassroots level. These seven are ASDC role. In summary, ASDC playing a multiple role and form setting standard to training, certification, placement, global competitions, and large scale projects, all aligned with building a skilled workforce for the automotive sector. Through the forums like today's expert group meeting, ASDC collaborate with domain leaders to identify the skill gaps and strengthen training programs and create actionable strategies to the workforce development. With this, I would like, this is the brief introduction of ASDC role functions. With this, I would like to invite our chairperson, Kiran Deshmukh sir, to share his welcome notes and set the context for today's deliberation. Over to you, sir.
Thank you, thank you, Arpit. Good morning, everyone.
Morning.
It's my great pleasure to welcome you all to this expert group meeting on virtual engineering, simulation, and modeling for automotive applications. I'm genuinely delighted to see such a distinguished gathering of experts, academics, industry leaders, and practitioners. Your presence here today underscores the importance of the topic we are addressing, a subject that is not only timely, but also vital to India's future automotive innovation and manufacturing capabilities. You just heard about the Automotive Skills Development Council, ASDC. Its core mission is to build a robust, future-ready workforce for the automotive sector by developing occupational standards, qualification packs, industry-aligned training curricula, and nationally recognized certification frameworks. Today's meeting is an essential step in that very journey. As we all know, the automotive sector is undergoing a dramatic transformation driven by digitalization, Industry 4.0, electric mobility, and sustainability imperatives. In this evolving landscape, virtual engineering, simulation, and modeling have become strategic enablers. They help reduce product development time and cost, improve performance and safety, and foster innovation. However, to harness these technologies effectively, we must build a workforce equipped with the right skills and competencies, right from technicians to researchers. The purpose of today's discussion is to identify those skills, understand the gaps, and collaboratively design a framework for training and certification that aligns with industry requirements, global benchmarks, and national skilling priorities. I'm particularly honored to welcome our esteemed panel of experts who bring a wealth of knowledge and diverse perspectives from both academia and industry across national and international domains. Mr. Viju Ramachandran, Technical Lead Manager, MathWorks, Bengaluru. Ms. Zaida, Manager, Strategic Institutions, MathWorks, Bengaluru. Mr. Rabindra Saha, Chief Technical Officer, Indian Registrar of Shipping, Pune. Professor Vinay Pratap Singh, HBTU, Kanpur. Dr. Nagvendra Kumar Kanoje, Postdoctoral Fellow, Sophia University, Japan. Mr. Nitin Banai, Director, Tesla EV Academy, India. Dr. Santosh Chavan, General Manager, JPM Green Energy Systems Private Limited, Gurugram. And Mr. Sukhpreet Singh, Managing Director, SkillNet, Punjab. We're privileged to have your insights and experience to guide this conversation. I'm confident that the outcomes of today's meeting will make a meaningful contribution to the development of a nationally recognized skill framework and support the growth of India's capabilities in digital engineering and simulation-based research and development. Thank you all once again for joining us. Let us work together to make this session productive, purposeful, and action-oriented. With that, I extend a warm welcome to all and look forward to the discussions ahead. Thank you very much.
Now, it is my pleasure to introduce the moderator of today's expert group meeting, Mr. Vikrant Vaidya. Mr. Vaidya brings with him deep expertise and experience in automotive sector, and he will be leading and guiding our deliberation today. His role will be to facilitate the exchange of ideas, ensure balanced discussion, and help us arrive at the meaningful recommendations. And with that, I hand over the proceedings with Mr. Vaidya. Over to you, sir.
Thank you, Arpit. Thank you, Deshmukh sir. Glad to be part of this initiative, and from my side also welcome to all of you. So I think we will go through a set of questions that we are supposed to address today as this group. And I already see a good suggestion from Dr. Banai that we should also have a group formed over WhatsApp so that we can continue the conversation forward. So maybe Arpit, we can do that during or post this meeting. So with that, I think let us start with some of the fundamental questions, and then we go to specifics as we move along through this meeting. So fundamental question would be why we think this course would be necessary, or this skill set would be necessary. This would be addressed to all of you. I would note down each of your responses. And what we really are looking for is where is the biggest demand for the skill set? Is it growing uh, both in terms of product engineering, R&D as we call it, as well as manufacturing engineering, which is also a rising sector for doing a lot of model-based development. So I would start with this question that what do you see as the biggest demand, and uh, why do you think the formal training in this sector is critical beyond what is usually covered in bits and pieces in the academic courses as well as on the job? Uh, yeah, Dr. Banad, you can start off.
Okay, so thank you very much, ASDC team and all the experts and the members of the this ecosystem. I will just brief everybody about me. I'm working in design and simulations from last 19 years plus, and I'm ex sciences, and I was handled different multiphysics problem with working with ISRO and automotive segment. And right now I'm working in a company wherein we have the EV greenfield plant, what we call Industry 4.0, and automation and all those things right now is happening in front of, in front of me. Um, am I audible?
Yeah.
Okay. So, sir, what is my take is like I have dealing with all academics and industry, and when India has an opportunity to work on design, what we call simulation design, driven product development. That is the need of an hour. If you see 90s and 20s, 2000, 10, 7 to 10 prototypes, like all these OEM, and they are taking to area and they are doing the crash and all of that. Now that is not required. Only you can make a product and you can roll out the very functional and very proven product. With the help of virtual simulation, what we call, there are different types of physics, and today's world demands multi-physics simulations, and that is the need of an hour. Only FEA will not work, only CFD will not work. We need CFD plus FEA plus optics plus POs and whatnot, like all these EMI, and all these technologies. EV, hybrid EV, drone, software driven vehicle, software defined vehicle, all this requires virtual simulation. And I think we are the set of people who can take this ownership and responsibility and deliver to our academics and the industry. And I'm sure this initiative is really helpful. I'm behind Mr. Arpit Srivastava to we have to execute this kind of initiative, and I'm thankful to ASDC team, Larry sir, and Kesi Gora sir, and all the people in the ecosystem, Deshmukh sir, for giving this an opportunity to all of us to contribute. And I would like to tell everybody in this ecosystem that I will take and make it happen, because I'm working with the IITs to NITs to all the colleges in Maharashtra and some colleges in Gujarat. So I will stop it here, and looking forward to your guidance and help, sir. Thank you.
Thank you, Dr. Banad. Ravindra ji, let's see, can go next.
Yeah. Can you hear me? Quick check.
Yeah.
Good morning, everyone. Thanks for the opportunity. Just quick one sentence. I come with over 32 years of experience with automotive, with Tata Motors and Tata Technology. So more than 200 product I was part of developing, and physically 15 plant for Tata Motors support, and all throughout the digital and physical, and work for the more than 100 customers worldwide in automotive, OEM, and steel. So, and recently I have also interacted with a lot of academia institute from IIT to NIT and all. So close to 20,000 students and faculties I have addressed and recommended the course of changes. So what is the challenges currently we face? If you look at that, academia is always giving as a kind of our institute is giving the domain knowledge. It's engineering aspect. The other aspect is very, very important. I call that as the first one is a one circle. Second circle is the digital technology, engineering. We calling here the virtual simulation, virtual engineering. So where we use the engineering softwares. Why we use the engineering software? Because it makes it the faster time to product design and development whenever we talk about the automotive. So that's very, very important. A third circle is the kind of industry 4.0 where there are the multiple levers are there. But current to the discussion, I'll talk about that subject is virtual engineering, virtual product design. What has happened in the last over 3 decades is that we have worked for the point solutions. We have worked for the standard solution like design separately, CAE separately, analysis separately, product design, all are separate happened. And what happens in the past that the data migrates from movement from one to other is always challenge. So one this is that we need to move from the collaborative integrated solution, which is not happening in the academia whenever skill is being built. And this is what is now all OEM softwares have built. Second challenge is which we see that design is there, change management is not happening, and but there are multiple versions are there, supplier integration is not there. So these are all related to the data, etc. They have the graphical, non-graphic. So those are needs to be merged together to bring as a kind of collaborative achieve there. Third point which I wanted to mention, I have addressed so many things. No one talked about the product life cycle management, right? Which is very, very important. I think other Tesla guy was talking about it, right? So it's very, very important that we bring a framework, which is the need of the skill, framing up how the project concept is designed, how the product is designed, different element of the product, and not only the mechanical, multidisciplinary, how the CAE validation is done. Nowadays, the trend is that CA-led product design is happening. Both goes together. And how the same product is done, how we manufacture green funding. So all this needs to be done on digital. Digital first cultures to be built, whoever it does it, right? And this is what skill is to be built, right? So across this area, the technology is available. Technology-led product to be developed. If you want to make the product, I wanted to make manufacturing also. We need to build the entire digital twin. We call all the process planning, layout planning, greenfield, brownfield, simulation, or everything, all into digital. So this is what is the gap. We need to really work with a small basic courses, advanced courses, and then intermediate also courses that needs to be built. And last is that nowadays the vehicle is not only just movement from one place to other. It is a kind of software-defined experience how you are creating. A lot of all this mechanical with link with the ECU, etc. But a lot of technologies are built which you can create a kind of a small model, and those are the skills is needed to be built. So this is a summary I would like to share at the moment, and while we progress, we'll talk about.
Thank you, Ravinderji. I'm as we speak, I'm also noting down this because we would at the end of this we would like to conclude with all of these points recorded. Plus, we are also expected to come up with some specifics as well. So
Thank
you. So Preetji, if you want to go next.
Yeah, of course. Thank you for this opportunity. So I come with a background where I was managing a government company with a mandate to support industry on digitalization, and happened to implement this with many OEMs and 8-tier companies. Now, the fundamental question which you were asking is why it is needed and do we really need it? So I have experienced, and I would like to put in this way. See why we need it, because it is cost effective. There is a misconception that digital technology is a very costly engagement, whereas when you look at the use cases across OEMs and big companies, it seems to be that the turnaround ROI is becoming more and more cost effective. Second, it adds to speed. It really gives you speed in bringing the product to market and making the manufacturing reach that excellence. So that is where it is required. Third is precision. It is more accurate. You can actually use these digital technologies to do a lot of precision, like aerospace industry and many other industries have quickly adopted it because they see a kind of precision which they can we can adapt to by using these technologies, which otherwise is becoming difficult by just using the hardware and other older technologies. Then the fourth thing which I see is it leads to innovation, right? You can try a lot of things in simulation environment, virtual engineering environment, digital twin environment, which otherwise you have to do it in more like you do it hardware, you spend more money, and then you ultimately come to know whether that will work or not. So it adds to innovation. And another important thing why we need it is because we see that OEMs and 8-year companies are very fastly moving towards this technology. So in case other companies like supply chain companies, they are not moving towards it, we are creating a huge gap. We are actually encouraging that gap because one set of industry is actually into the technology which is more IT integrated. Another set of companies, they are not having, one because of manpower non-availability, two because of the kind of gap we have created. So it is most needed. And also you can see that the new products which are coming in market, which are more OT IT integrated products, like there was someone talking about product lifecycle management. Now, when we see that a lot of OT IT integration is already happening, then if the workforce is not capable of handling those kind of products, those kind of machineries, then ultimately it will lead to seeing an industry a challenge in managing that kind of manufacturing process. So there are many advantages or USPs I see of virtual engineering, digital twins, and simulations, which otherwise, without using them, it will only slow the pace of industry. And automotive as an industry, it is very competitive industry. You really need to push hard in terms of workforce to get people ready so that they can start leveraging it. I quote an example here. We happen to give access of this technology to about 1 lakh people in Tamil Nadu in my past company. And I could really see the kind of new innovations and startups which are coming out just by providing them the right tool and the right skill. So I think when you give a lot of access of skilling and technology to any learner, they will evolve and they will come out with a lot of interesting things. That is what I want to submit. Thank you.
Thank you, Sukhpreet. I think you mentioned multiple points, all equally important and very practical in terms of how they address directly the product, its quality, its time to market, and so on. I would move on to Nagavendraji, if you can share your thoughts next.
Good morning, everyone, and it's a pleasure to hear all of you. And thank you, Arbit, also, and all dignitary members. I am from Sophia University. So my point is like usually I would be happy that we are making we are trying to move forward for the Make in India initiative. So like in a perspective to look for a Make in India perspective, it is very important that we have to connect the 3 points which is to be addressed. Like first, the global acceptance. The second is what you are trying to build up is the workforce, and the third, the technology. So all 3 aspects has to be correlated so that the global acceptance of Make in India is to be nurtured in India. So if we are trying to make the people addressing the future solutions or prepared for the future solutions, there must be like the workforce should be such a way prepared that they could move to another countries in prestigious companies, work in prestigious companies too. So in this point of view, the point is like we are going to build a global acceptance for our automotive industries, the skills. So whenever you are preparing any workforce, they have to be ready to deliver in any country, or we are collaborating with any other company from Make in India initiatives. Like we are for Japan side, like the PM Modi has said that there will be exchange of people, like 500,000 people will be in for next 5 years or next 10 years. So in that perspective, we have to think about to prepare the workforce. And in that case, like if our workforce is moving to Dubai, where also we are finding that it's a hub of some European companies building their cars, and they are to and exporting to. So like we have to think about not as a technology perspective too, but we have to make them ready for the new technologies so that our global acceptance could be prepared. So our global acceptance has to be prepared from now onward, that like when you are thinking of preparing a technology or any car for a market readiness, the also the data is like to be shared in such a way that the standard like 26362, I think I'm correct maybe. So the standards for cyber security and all should be catered very accurately, because this companies will be like needed those data to secure scenarios in Indian perspectives, like whenever they are running their vehicles in made in India perspective, or maybe in future ready for the Indian scenarios. So that also a very prominent part. So in coming session, I would like to look into more brainstorming things. So for now, just this is my initial comments about this course. Actually, thank you.
Thank you, Nagvendraji. Yeah, it's a slightly different perspective that we have been hearing. To be globally competitive and acceptable, we also need to have the quality levels as well as the development process levels to the at par, if not better than what we see globally. So I would now like to move on to Zahida from MathWorks. So what we are kind of seeing, you have experience in terms of looking at what happens globally against what happens in India in terms of virtual engineering based development. So like to hear your thoughts in terms of gaps and the need.
Thank you, Mr. Vikrant. Can you hear me very well?
Yeah.
All right. Okay, so good morning, everyone. First of all, I'd like to thank ASDC and Arpit specifically for inviting my colleague Viju Ravichandran as well as me for this particular platform. And it is of really honor actually to be talking about this particular case of where we want to kind of develop skill-based courses or skill-based curriculum for automotive industry. I think I've spent literally close to about 1.5 decades with MathWorks, and prior to that, I was actually with another company called Cadence, again in the space of EDA, software and EDA simulation. So I have a little bit of a knowledge in terms of I've been witnessing the evolution of the academic spectrum, and what I have observed is that most of the academic institutions actually focus on the knowledge creation, which is good, which is necessary, but somehow they have been averse to actually building skill-based content or curriculum that actually makes these students more not just employable, but also actually solve engineering problems, contribute to initiatives like Make in India and so on and so forth. So my observation is that we need to kind of come together as a team and look at what would be some of those areas where we can actually look at, or many of the speakers before me have spoken about a lot of these technology trends that are governing the automotive industry. And today, if you look at it, software is almost everything, almost about 60 to 70% of what makes up an automotive. So understanding these intersecting technologies, solving a problem at the system level. And these are some of the imperative skills that are required. And engineering design tools and simulation tools such as MathWorks or many other such similar softwares provide that kind of skills necessary for the students or the new graduates. So when we are putting together curriculum, I think it's very, very important to kind of infuse these technologies. And one of the speakers mentioned about how this kind of fosters innovation. And I think, this is something that we have seen, because at our company specifically, we actually sort of have a lot of initiatives that are looking at collaborating with industry, collaborating and making sure that the students are working on real world problems and so on and so forth. So all of these are very important aspects of a particular curriculum or skill based courses that we will put together. And how we will actually provide these interventions is also something that we need to kind of think through, whether these would be, what would be the size of these kind of courses, how they will be administered, so on and so forth. Many times what I've seen in an academic setup is that they are offered actually as something like a value added course, and not something that is integrated into the knowledge creation or integrated into the core courses that are being taught. I think we need to kind of figure out or have a modular structure that is built, so that these courses or the content that we developed through this platform or outside of this platform will be integrated and seamlessly integrated into the knowledge creation. And that I think is very, very important, because we should not look at them as silos. Being knowledge is something that generate at the academic institutions, and for skill we go to another entity like an edtech company or an edtech solution provider, etc. But how do we kind of integrate that so that the students who come out will be well-rounded individuals or engineers who can solve problems? And secondly, I think what is also important is that the idea of elevating the students to understand about the system knowledge, like solving a complete system and not looking at problems which are very siloed in nature. And I think my colleague Viju Ravichandran will also talk about some of the experiments that we have done in developing certain curriculums in different areas. There are multiple aspects that are transforming the automobile industry. There could be AI, there could be like autonomous driving, robotics, and so on and so forth. How do you infuse all of these technologies? How do you make sure that we create the learning agility into the students is something that we need to incorporate through our curriculum as well. So these are some things which I think should be something we need to bear in mind as foundational aspects that we need to kind of think and come together and understand, use and leverage tools that are available, and see if we can kind of improve and enhance the skill of the engineers. That's my initial thoughts.
Sure. Thanks. Thanks. I think looking at students, reflecting back on my own student life, we hardly learn tools, or we learn tools as tools and knowledge as knowledge, but never till got down to the job, never thought of how they will actually integrate. And tools should be looked upon as enablers in any problem solving, rather than as a separate subject or a topic. Like you aptly mentioned, they are often looked upon as add-ons or something that you learn in addition, not as part of or integrated well with the curriculum. So point taken. I'll move on to, I think we have more people representing. I think, yeah, Dr. Chavan, if you could come in at this point and share your thoughts in terms of requirements, looking at what JBM is experiencing in terms of their recruits having these skills, or is there a gap that needs to be addressed?
Sir, Santosh sir has not joined us
Okay.
due to rain. He has
Okay. All right. I would next. I think there are some people who had joined, but won't see them anymore. But Dr. Singh, if I can bring you in at this point, if you are available, would like to hear your thoughts as well.
Hello.
Yeah.
You talking to me?
Yeah. We have
Acha,
your thoughts.
sorry.
Yeah.
A very good morning to eminent panel. I have known Arpit, but others I don't have. So I'm very thankful to all of you for inviting me. And I, as if I feel like I'm the only person from academia, or somebody else is also there. So I have a lot of burden on me. To begin with, what I have heard from your discussion, for students, the major thing is how we go about it, how we go about this subject simulation. So simulation basically when we are representing the real world and with some models and the process. And basically what in academia what we do is we try to make them understand that simulation, with the help of simulation you can easily understand the concept. Like suppose if I'm talking about developing a stress or how the thermal stresses will be developed, it is much more easier to make them understand how the thermal stress will be developed in any automobile, any component, and rather than being calculating. Similarly, if you are calculating drag or if you want to change the drag, it becomes very difficult when we are going theoretical. So when we are using simulation tool, it becomes much more easier. Then question arises why this is not much more prevalent nowadays is the trainer who is actually giving them knowledge. If the trainers are not trained enough, if they are not going properly, then they will not be able to make the students understand the power of simulation, the different simulation tool we have, the advent of AI. If we are not able to integrate this entire concept, and if we are not able to tell the student what is the benefit of this, what is the power of this system, then definitely student will be like moving away. We are matlab, entire, if I see different beside barring IITs, barring NITs and all these, if I talk about the regional engineering colleges or even a private engineer, this simulation type of subjects are only just for the sake of it. They are only putting in the curriculum just for the sake of it. If we don't have the trained professors or teachers who are going to tell the student about the power of this type of tools, then definitely students will not show any interest. And even I'll tell you, if I'm sorry for that, I have seen most of the industry, they have very little in this R&D structure. They have some limited softwares, and whatever softwares they are using, that is not being actually provided in academia, if I'm not wrong. So suppose, like say for example, in Maruti, they are using Siemens, but in the most of the colleges, academic package is given by ANSYS. So if I see the gap, well, people are learning ANSYS and they have to learn the same, I think that Siemens software. Then again, this type of difference comes, and whatever seniors are there in the company, they give the feedback, and they know that once you go into the company, they give this type of training to these students, and they don't want anything else from this. So it is from both the industry as well as academia, they have to work together. If really industry people want that we should have a trained workforce, then they should train the trainers at the academic institute also, and they should also try to open certain industry supported labs. If we'll have that type of lab, the exact type of requirement can be generated. That is what I feel.
Thank you, Professor Singh. Yes, I think it is very imperative that what Zaida ma'am said, that integrating it into the curriculum. So at the same time, the trainer should feel that it actually enables them to teach a topic better, involving simulation tools which give the representation of real world, as you said. But for that, they themselves have to be trained, have to realize the power, and be confident about going about doing that. So a very valid point. I think, Arpit, we have gone around the room. Did I miss anyone?
Yes, sir.
Just take through the participants. Yeah. So we can go to next to some specific questions. This question was just a starter to the topic, but let us go to a few specific questions to our experts, specific experts. So next, I would like a little bit elaboration from Dr. Nitin Banait and Dr. Nagavendra on where are we lagging, and what we talked about the global relevance, acceptance. We talked about going into a complete end-to-end virtual model like digital twins. Where are we lagging in terms of capabilities, in terms of those skills in India? If you could elaborate a little more, that will help us. Uh, uh, Dr. Nitin, you would like to go first?
Yeah, yeah. So, Tim, what my experience is like whenever we see syllabus from IITs to normal colleges, the challenge is there is a lack of initiative from the colleges or universities or the whatever the ecosystem it has. Uh, so when it comes to real implementation, if you see this Baha team or Supra team and those kind of team, those people are only very keen to implement that because that is the mandatory things when they are going to participate in SE, Baha, or all this kind of competition or the global competition. If these are not there, the people or the students will not participate even. Okay. So the challenge is when you do this kind of let's say for example, future is all about E kind of competition, wherein you need multi-physics team. If you see any team in any colleges, including IITs, the challenge is these guys. So these teams don't have the multi-physics team. Basically, major teams are coming from the mechanical branch, and the other branches participation is almost like negligible, and that is not good situation we are in. So if we barring some colleges initiative and universities, like at all other places, what I have seen is this needs to be more involvement from engineering, involvement from electronics and telecommunication. IT and computer is the need of an hour. Just by saying AI enable this, AI enable that is not going to help, because AI needs a lot of valid and proven data, and that is not happening. And we are just on the slides and presentation, we are showing university has done this, colleges has done this. So that is the way forward. And you see, industry needs a lot of skilled resources, and that is not available. Even industry don't expect the person or student or student deliver from day one. So they will give a lot of time, but the student don't have the appetite to understand the basic stress strain diagram. Even the what are different kind of materials, how they behave, these basics are not there. And I see a lot of initiatives are needed from the academics point of view. And industry nowadays, a lot of proactive efforts from the industry to bridge this gap between industry and academics. So these are my observations. I will stop it here, sir.
Sure. Thanks. Dr. Nagarendra, if you want to add on
Yes,
this.
yes. Thank you. Thank you, Vikrantji. Actually, I would like to add a little bit, actually. We do have the very drawbacks in our system, but what I've observed, like in Japanese perspective too, is like when we look the teaching here is like when it's a system they follow also, and also they teach the CAD and CAM together actually. So in our Indian perspective, the level of colleges we have like a pyramid of IITs and NITs, the skills actually somewhere mixed up and could not able to uh, from top to bottom. Actually, we have swam courses and also, but like when we look into the technology should spread over all across the country. That is one of the important part we actually lacking actually when it comes to swam or any course. Actually, when any IIT is trying to build a technology or any teaching methodology, it is missing from it. Stick to the top. Actually, it don't spread actually. So there may be, the point is like when the students from the other regional college or maybe the coursework is just limited to the laboratories, or even those laboratories won't have enough infrastructure or the experimental setups actually. But when in terms of simulations, actually, there may be, I could say that uh, the IITs should have such a way that I recently seen somewhere that center of excellence is coming. But centers of excellences, when the technology is spread across the country, the students of the institute at lower hand don't even understand that technology, and it's already been market. So the students have to fight for the getting into a job or a technical training skill education center. There maybe he could leverage his knowledge and could get far to be ready selected for an industry. So in such cases, I feel like the syllabus or any course which is to be ready for any student is to be dispersed all over the country equally, so that the person who is trying to teach any student at any level of the institute, they must equally treated, so that what he if he when he finishes his graduation or any course, he may be able to explicitly able to deliver actually in an industry. So when I could find that even the Japanese company comes for an interview, or they actually do a lot of interviews all in some institute across Pune, or I heard too. So when they go for an interview, our students should not be like a blank-minded or any, like those courses should have a proper, I could say, eye-catching knowledge-based uh, things to him, so that he could be able to say that confidently to that I could be able to deliver any company if he has to be hired. Apart from technology or like courses, I could say that the technology is like very much changing these days. So if we preferably saying that the hands-on practices says, then it simulations comes to the very important part. So simulations actually, the syllabus usually preferred like on some very heavy software which are like NCs and Abacus or. But when we look into a practical aspect, there is a number of aspect in a automotive sector is not just only simulations, the designing simulation scenarios also, like what is where this vehicle going to be run, or any scenarios like to be understood by any student, so that if he able to learn a software or any soft skill, he could immediately just simulate that situation in that software, may help him to understand the knowledge best very better, because there are many engineering concepts are there which are to be learned during its graduation, like dynamics, NVH, or a lot of technical things which are very much needed to be understand fundamentally. So that fundamentally understanding is missing from our student these days, because of the coachings and kind of a logical thinking is not building in our student these days. I'm I'm not saying to our system that it is not good or bad, but the logical thinking is need to be built from the very first, from the childhood, and this is missing in our educational system, because with the coming of AI, the logical thinking is much needed to a student, because AI could do all the other things, and that's why the logical thinking is missing somewhere, and the student are just trying to simulate only mathematical things in formula, or trying to solve in this way. But once they are getting into a very good institute like IITs or some foreign institutes, where the logical thinking is symbolizes the critical benefits, actually I could say symbolizes the critical benefits, because AI will be benefiting all humankind with a critical benefits, like where the human will lacking. So those critical benefit will be deal with individuals. Like if you find a car as per the any millionaire, he could customize as per like his comfort level. So this AI could maybe will able to fulfill his choices, or in future the Japanese companies are working on this perspective only. The model is OpenXR and all. These are so they are fulfilling the what I could say masses requirement. So I believe that there we have to think about it. So the courses need to be framed such a way that they are the knowledge should be dispersed all over continent equally, and we need more people to be ready for the industry, and they could be hired, because no industry is not prepared nowadays to, and there are a lot of applications comes in interview, and they immediately just by using AI or anything, and they shortlist number of, and people, they are just their CVs are thrown away. So for that case, we have to understand our future readiness for the students and syllabus. Thank you.
Thank you, Nagavendraji. If I quickly sum up, collaborative approach, the reach of these will be severely challenged if we are not able to, move the expertise and make it accessible to everyone. Mentioned about Swayam portal and other digital platforms which could be used to do this. You also answered one of my next question, which was, what do you see fundamentally different in terms of in your experience in Japan versus India? So I think you address that in terms of how the logical thinking and how it should be imbibed through the education and the student life to take it forward is missing, or it is lacking. And finally, AI complementing. So a lot of times people have this fear or concern that AI is replacing people. It's actually supposed to complement you. It's supposed to be kind of filling up where humans may actually find it difficult to do things. It's similar to, I would say, when we resisted mechanization, right, or automation
Yes.
in manufacturing. So very good points. I would like to move to MathWorks team, Zahida, Viju. If I saw the messages also on the chat, I will have Arpit share it with me. Also, Prabhaji has put up some really valid points. But if I can quickly come to you, Zahida, ma'am, and understand from you, in your experience, what are those specific skill gaps that we can address through some of these courses that may as start off as skill based courses, but eventually we aim to have them part of any and every curriculum.
Yeah. Thank you, Vikrant. So the thing is that I think I've heard that there are limitations within the academic system, and while we kind of agree to it, but also want to highlight that some of the institutions have been, or at least a large number of them, have been evolving and kind of putting together or putting in place some good practices to kind of ensure that they are continuously enhancing the skill sets, etc. And in MathWorks, we roughly actually sort of collaborate with at least 400 plus good institutions across the country who have been leveraging these digital tools or the simulation tools that we have to offer to kind of enhance their curriculum, bring about some changes in the way the students are utilizing it, etc. And to your question in terms of the skill gaps, we do kind of look at or at least have observed or hear from the industry what are some of the skill gaps that we are seeing or they are seeing with the engineering graduates. But to talk about that, actually, I think we have to actually look at sort of an example. And at this point, I think I want to kind of request my colleague, Dr. Viju, to kind of talk about this a little bit, because he and his team actually work very closely with both industry and academia and have a good perspective to provide to this team here. Viju, are you there? You're on mute, Viju.
Yeah, just unmuted. Yeah, hi. Thanks, Vikrant. Thanks everyone for your perspectives, and it's very nice to see that there's interventions coming from a skill development council towards this. And as Ahada mentioned, MathWorks works both with the industry segment, meaning we are one of the leaders in the automotive industry segment from a product perspective, and also we do have a lot of engagements with the academic segment as well. So I work, and my team, there's a team of 15 engineers who works primarily only with the institutes in the engineering and science space. So we work on a daily basis with at least 150, and we have experience working with 400 institutes. So a few of these are based on what our observations are from these interactions and also what we've done. Yeah. So I did want to share a couple of slides. If it's okay, I could do it, or I can voice over whatever works. But overall, I can. What do you prefer, Vikrant? Do you want me to share or just voice over? What do you feel?
Sure, we can quickly have visuals usually complement, so we can quickly do that.
What's that?
Yeah, visuals usually complement the voiceover, so
Sure. Let me do that then. Cool. Just give me a minute. No, there's apparently sharing is not on, so I've sent a request. That's okay. I can. Okay. So from a perspective of, what are the skill gaps, right? Meaning I'm going to take it both from a pedagogical aspect and a little more. So the thing is, students are quite good in terms of understanding concepts. Okay. But when it comes to linking it to the applications, that's one thing. And I'll give you an example shortly. Yeah. And then there's an aspect of what we call systems thinking or design thinking at a system level. Yeah. And a lot of institutions that have introduced that in the first year level, instead of introducing programming, which has basic selection sort, insertion sort, they call it engineering exploration. And they're able to say, take some socially relevant, locally relevant problem statements and sort of solve this without being corrupted by engineering techniques. So that design thinking is something that we've seen. Yeah. And we need to ensure that that's widespread. It can't be just in a few institutes. Yeah. And also the whole aspect of interdisciplinary thinking. So I was in a board of studies in JNTU Hyderabad, and the first day when I said, I think the electronics and communication students should pick up robotics, they said, oh, robotics is seen as a mechanical engineering course. Students won't pick that up, right? So that ability to work on intersecting technologies or interdisciplinary approaches is another one, and which is where the whole aspect of systems engineering or systems thinking comes once again. They possess good algorithm level understanding, but they don't know how to integrate them. And then again, coding versus modeling and simulation, people think, if they know Python, they are AI experts. They don't understand the mathematics, statistics, and optimization behind it. Similarly, for them to model some control system, they need to understand what the background is. Just because they have a tool knowledge, it doesn't mean that they have the background, the technology background, right? And of course, there's soft skills that we talk about. Yeah. I want to take an example of, two automotive technologies as such, which I feel, could and which I'm sure will come up here. And we have experience with one of them at a large scale. So
sorry, Viju, I think you can present now.
Yeah, I can present. Okay, let me share that. Okay, sure. I'll just maximize it. Is my screen visible to people?
Yeah.
Okay. So this was the thing. So as I said, linking the concepts and design thinking, and then interdisciplinary approaches, the whole aspect of systems engineering, and then coding versus modeling and simulation, and soft skills. Yeah. And we are aware that, software-defined vehicle someone mentioned. So there's a whole aspect of AI and autonomy. And then this aspect of electrification and connectivity. Yeah, I'll skip a few slides, but I want to say that the core engineering branches we saw back in 2018 when we started working with a company like Bosch. A core engineering branch like electrical and mechanical were well poised to handle the EV revolution because they were talking about concepts on power electronics, they were talking about concepts on battery modeling, battery management systems, thermal modeling, all of that, which is critical to electrification, right? So we were able to talk to people saying that, hey, you're teaching these concepts and this is something that's important from an electrification or an EV perspective. Yeah, so that's something that we've done. We'll talk to you about it. But to talk about what's upcoming, automated driving or autonomous vehicles, when I say that, it integrates knowledge from multiple engineering disciplines. You can be an electronics and communication, you'll see why, or electrical electronics, computer science, mech, or systems engineering, and there's mathematics, sure, someone mentioned about it. Yeah. So if you notice, there's an action cycle here. It's called the perception action cycle. Most of them may be aware. You need to detect the environment, you need to plan, and then you need to take the control and put it on, right? So when you look at it, when you look at each of these buckets, which is perception and AI, or sensing and fusion, planning and decision making, or control systems, which is essentially what this is about, it has a basic things that are there in an electronics and communication vertical, or it has something that a computer science student learns, or even an electrical or a mechanical student learns. Yeah. It's just about linking, like how we say maths is taught, but not linked to engineering applications. Engineering techniques are taught, but not linked to the actual real world ones. Yeah. In an image processing course, you could tell them, okay, this is how you look at perception, right? Or in a signal processing course, this is how LiDAR data comes back to you and you sort of localize things. Or in a control systems course, you could talk about Kalman filters and stuff, or maybe an advanced control course, right? So at least 50% of the topics that are taught in automated or that are a part of automated driving are taught in a basic undergraduate course. So it's not that the students are not aware. It's just that they're unable to link them. That's primarily what it is. Yeah, I think this is the gap. So there's a gap both from a skill perspective, but also a learning slash teaching perspective. Yeah. And in terms of interventions, what we've done, we can do it when we do the next round. There are a couple more slides I do have, but this is what. Zahida, do you want to add anything on this front before we?
No, for that particular question, I think this covers it. But I think we have a little bit more information to share how we have been working to kind of sort of bridge this gap. But we'll come to that actually in the subsequent discussion.
Sure. Yeah. So I think we would actually be leading into that discussion. Unless anyone has, I don't see any hands raised, but if anyone has anything to add, or we can move to the now actually
Just
looking at our
just
yeah, sure.
so
Yeah,
a couple
please.
of points. I think Bizu and Jahida very well mentioned, right? When we talk about in my 33 decades of experience, in fact, this math labs gives a platform where the lot of innovations and discovery things happens, and every engineer who is graduating, he should go through that. It's a basic fundamental of engineering. That's why I have built the entire autonomous vehicle, what Ravi presented in the 6 months of end to end, and built with help of the math lab and others. Similarly, he was mentioning, Mr. Professor Nagvendra was talking about a lot of challenges. He explored that the technology, engineering software can be made available on cloud, because all are available on cloud, and all engineering colleges, after learning the subject engineering in the college, they should learn about this technology in the cloud, log in use in the cloud. That kind of some platform ecosystem, if you think of building in our country, right? So that, like I said, everyone should be able to access it. Wherever he is there, internet is there, he can access it. So something like that we should really work. In fact, that's my thought.
Sure, that's actually a great idea. Moving into some of the solutioning aspects. Thanks for that. Uh, uh, we can then move into so we have kind of addressed the problem statement through this first phase of discussion. Why the skill is necessary, why what we are lagging in as a country, or even specific to certain sectors, industry, academia. So now if we can get into it, and some portions, as we discussed, it's human to think about solutions, particularly if we are in a room full of engineers. Some of the solutions are also peeping out of the discussions, which I am kind of recording as we go along. But would now like to look at specific how we could address this. What could be the look and feel of this intervention, be it a course, be it a skill-based course available for everyone, be it a recommendation to the academia that let us do it this way. So, would like to hear again from across the panel how you envision a first initiative. I'm not talking about full solution yet, but how would you envision this solution? Arindam, I see your hand raised. Probably we can listen to you first before we go in.
No, I was just trying to, based on the various experiences and the inputs that I've been hearing from the various experts. I just had a very specific input in terms of how we could look at in the context of integrating it with the curriculum. There is a provision now with specifically AICTE in terms of approving programs under what is called a minor degree. In India, we didn't have this concept of a degree and then a minor degree kind of a program. The usual degree, 4-year degree program now, as per NCRF, is 160 credits, which is 40 credits per year. There is a provision that students could opt for a minor degree, which is like a dual degree concept at universities, which is an additional 20 credits, which takes the overall credits to 180 credits. And these 20 credit program design can be specifically on a particular area which is fairly industry linked. In fact, we as a council, we have already submitted about 5 different technologies and hardware areas, etc., which could be, once it is approved through the AICTE as a central stamp that this curriculum is kind of approved by AICTE. We could take it down to the colleges for further adoption of this. And therefore, if we could also think of doing, other than the skill-based courses, which are limited period, additional courses for interested people who can do it as like a finishing program for their graduation, etc., we could also try this new route of offering a simulation engineering, or whatever terminology we can think of coming up as a very interesting term, and also of slightly aspirational for the students to take this, because eventually the colleges will also have to market this minor degree concept to the eventual user, which is the student and the parent. So some structure like that could be quite useful, is what I thought.
Sure. Yes. I think if it is within the formal structure, it has much more acceptability within the students as well. So I think this is a very good point.
Really, it's a very nice point, Mr. Arindam, you mentioned about it. So I've got a query in mind. The student will get a minor degree also, some certificate they get it, how it works?
So basically today you get let's say a bachelor's in mechanical engineering, BTech in mechanical engineering. So a minor degree will typically say that it will be BTech in mechanical engineering with a minor in simulation engineering, let's say. Okay.
And the individual college can directly approach AICTE or ASDC help through that?
So the mechanics are still kind of in the works because it's a fairly new concept. Okay. What we envisage is that the course will be approved centrally by AICTE, and then each college it's easier for the college to kind of adopt it because it is centrally approved. Otherwise, each individual engineering college will have to go to their respective universities, board of studies, etc., for approval. Here also they will have to go to the board of studies, but because it is going to be like an AICTE stamp, it's likely that the board of studies is just more of a formality in that sense, if the college is willing to offer this. ASDC largely plays a role in terms of facilitating the structure, the curriculum, and probably providing anchoring of these programs, enabling conduct of faculty development programs, along with industry partners, etc., which we can work with. On some of the areas, like we've designed one program with Delphi TVS, which is on common rail diesel injection systems, a minor on the basis of that essentially. So there they have offered that they will provide their experts to further train the faculty in the colleges which opt for these kind of programs, etc. So something like that will eventually emerge, which has a better connectivity between the academia and the industry.
Very nice, very nice. In fact, the student can learn additional skill which can give the job.
This type of system is already in place. National education policy, the NEP courses have been implemented in entire universities, most of the universities. So they have this type of system where we have a minor degree system. So a student can be BTech from mechanical engineering and he have a minor degree in any computer science or whatever courses you are planning. Any university can plan for that. So that system is already there. Even most of the
Yes, sir. I think the system is already there. It's just that, today, I think a lot of colleges are offering a mechanical engineering along with computer science or electronics with telecommunication, this kind of a thing. I'm saying can this be more industry oriented rather than another branch of engineering oriented?
If you look at the mindset of the students, they are always interested in learning new things. If you can make the learning more interesting, they are more into it. So whenever new things comes into picture, students are much more bound to it. Like they have a feeling for learning new things. So it is important how you make them learn these things and who is going to turn, because they have a lot of questions, queries. So whatever trained teachers or whatever faculty we have, they have certain limitations. So this is what I felt ki when the students starts asking questions. So when we have a lot of new softwares coming into pitch, then these faculties are not able to fulfill their queries. So there must be some system to where they can address these type of their queries, or some industry people should they start their own website or problem solving system where the students, if they want to learn something new, because students have this knack, if because there's already a lot of things, lot of conventional things are available on website, so they get lot theoretical knowledge from the website. But if they want to learn something new, they try to search website. If you have certain websites or certain problem solving areas where they can be their queries can be solved, then it will be better. So this implementation will be much more easier. That is what I feel.
Yeah. I think if the need is created through these means, they would automatically gravitate towards learning these skills. Yeah. I see Nagavendra and Viju's hand up. Nagavendra, if you want to go first.
Yes, very good thoughts coming up actually, and I appreciate this thought. But parallel systems are not just with the degrees are quite appealing actually. We want that the technology or any glimpse of technology whichever enters Indian market should be like in a so media in media actually, or anywhere. So like in that case, whenever I found that here any in Japan, like there are specifically labs which are doing a coordinating industrial and together collaborative work. So they showcase their achievements on their websites or something. Even I think Indian IITs and NITs do that, but specifically those are just belong to the professor achievements, not with the industry, or I could say any lab perspective that makes not makes a appealing kind of thing, because the student just has to visit a professor website all the time, or it won't ever go because it's so technical to understand his website or any dispense of work he do in his websites. Or but when it comes to the laboratory or any industrial collaboration works, it makes a eye glimpse to any student that yeah, the work is going on, and the the output is in the market or anything. The media comes under it, and media also tries to uh, uh, go to or more students actually to showcase their work actually. But when it comes to parallel degree or something, I feel like somewhere the center of excellences should do some virtual things, like anywhere any institute which opens a center of excellence, he must utilize AI actually to solve the queries, and also showcasing their work together with the professors and registered the students actually. This could be like any more number, not like any cap should be there, so that the student should go through the technology fast, and the lifetime of the technology could be read by the student. He could go get notifications, he could get more the the lifetime of the project going on, because usually the output is associated with only the some when professor do with conferences or patents actually, and it takes some time to be displayed in the in anywhere in the media or somewhere. So the AI should utilize this thing, that the student when registered on a center of excellence which is parallelly working with academia, and it could register, the student could register, he could see the lifetime of the technology. And even the laboratories should be given such a way that if anyone, a student is there associating with the laboratories, the work, the industries in the project are coming up, going on, and he could see the latest technology, and notifications should be come to him actually. That will help him to be connected all the time to the latest technology. So this is the perspective I am feeling, that this kind of syllabus or coursework should be uh, made from the center of excellences, because they are working on latest technologies, and the professor are usually working on the fundamentals, like, so they could be busy with the conceptual things, but what is the life time going in the technology, or procedures going in the technology, they must understand from the collaborative things, like uh, uh, how the simulations goes, how the output comes, how the this outcomes are utilized in the industries, the patents are filed, and what I could say, like copyrights, all should be. But this could be a place where they could not able to copy anything, like somewhere data should be privately secured, and they could be the part of the project, but not able to take out outcome from anything, but utilizing to uplift his understanding. So there may be something parallelly, this could be a workout, we should work out, and the technology will be in the public domain, but like we are happily to show the student that they are registered, and in future they will be able to learn about the technology, and they could able to work out in such big companies. So that sex, if any, there may be center of excellences in the environment in India, a lot of, or maybe we could propose such kind of what I could scenarios to them, and they could understand the present technology with this. So this is the one of point I'm trying to say. Thank you.
Sure, Nagwendraji. Yeah, I think now it comes to mind that lot of times the industry-driven labs, if at all they are in the academia, they are usually CSR, not actually engaging with the academia to do applied research, applied problem solving, which is more prevalent in Western world, or even as you mentioned in Japan, where industry works very closely with academia, not in terms of just providing infrastructure, but providing real world problems to solve. And believe me, I mean, having worked in OEMs where we know there are many problems to be solved, which we are not able to provide to the employees because of the bandwidth constraint. There are many things we would like to try out and which could be tried out in academia with those sponsored projects, and particularly in simulation environment, which doesn't require as much infrastructure as a physical lab as well. Also, what I see is you rightly pointed out the concern that the data privacy or the invention or the IP leaking through while it is being developed is one of the concerns. And if we can address that in the academics, that yes, there would be mechanisms in place to ensure that that research stays within the purview of the whoever is funding that research, then more of these collaborations are expected to happen. So yeah, thanks for that point. Viju, I think I'll come next to you.
Sure. I want to address at least 3 points that came up here. I think one was the AICT one, another was the minor, and then you talking about the industry projects. Since you spoke about the industry projects, yes, again, we have been doing a lot of these industry academia roundtables, so not lot, two of these industry academia roundtables. One was at the MathWorks Automotive Conference in Pune in July 29th. So there was a person from Tata Motors Pune who said he's been instrumental in providing 90 problem statements to a single MTech program in one institute. Yeah. So there is a refreshing change around, the industry problem statements coming in. So that's one thing that I would say. We're also seeing a lot of that as an interest from, say, there are what are called the technology innovation hubs, which I think is one part where there are these Chanakya fellowships and everything that go out in terms of solving problems and stuff. So there's a lot of a movement in that space, if you will. Yeah. The second one is the AICTE approach. So AICTE, of course, we had the new national education policy that came out in 2020. Then AICTE had its own model curriculum, which they presented, and they also had model curriculum in emerging technology areas in 2020, which had around 8 of them, including robotics, AI, and many others. Yeah. And interestingly, Zahida can add more. We have partnered with AICTE in sort of figuring out how to upskill faculty, like what was mentioned, train the trainers type of a setup for a course on EVs. I'm just going to share a little bit on that front. Again, I'm going to go back to sharing my screen, if that's okay. And Zahida, feel free to chime in. So there you go. So essentially, so two things. So there is a structure which will come up, but what I wanted to show you was this. That is, we do have a full-fledged, say, 40-hour course that's used, by a lot of institutes. So this took into account that, hey, there are students that may want to take a full-fledged course on electric vehicles. And we said, okay, let's split it into parts, which would be around how do you introduce them to modeling and simulation, and then what we call model-based design. A few people might be familiar with that. And then there's the whole aspect of motor simulation, battery modeling, thermal modeling, and then how does it have the vehicle dynamics component and system level modeling. Yeah. And how this worked was, for us, we ended up taking 5 days of faculty's time. We had, on the next slide, you'll see a little more details. And we actually trained them on each of these modules. This was hands-on training. So if you notice, there's battery modeling, which was 90 minutes, or BLDC motor simulation and control, etc. This could be taken as a full-fledged course, an elective with institutes that have curriculum autonomy, and they're able to do it, or they could, a teacher teaching a power electronics course could possibly introduce just the power electronics simulation component. So that was possible. It's modular in nature, but it's also a standalone course. So what MathWorks did with AICTE was this. Zahida, do you just want to mention about this, and then I would go back to the minor when you prompt me. Zahida?
Sure, Viju. Thank you so much. So when we did the faculty development workshop, we actually started it and kickstarted this in Coimbatore with a 5-day workshop. And as Viju had mentioned, that we covered different parts of an EV vehicle design, and it was widely appreciated. And it actually prompted us to look at talking to ASCT and see how we can incorporate this through their program called as the Karyashala. The Karyashala aims at training a number of educators in terms of emerging technology areas, and which is what we presented to them about the success that we had in association with a consortium called as the ICT Academy of Tamil Nadu. And then we actually sort of presented this to the chairman of IACT, and that's when the whole Karyashala the project actually sort of envisioned and was created. And through that workshop, actually, we were able to kind of hold this Karyashala workshop in 2 different locations, one in Chandigarh and one in Pune. And through that, we actually sort of, as a pilot, we trained at least 100 educators on the complete EV workflow. And these was organized and facilitated by AACTE. And this was the follow up from that workshop was that the participants or the institutions that were part of that particular workshop were going to go back to the institutions and incorporate this as a course that they can offer, either as complementing their existing courses, or they could offer this as an additional course, as a value added course, or as an elective, etc. And this is something that they had actually agreed to, and some of them are already talking to us in terms of incorporating these courses. Another thing that came out of this whole program is that we were able to kind of advance the discussions around a minor program with AICT, which Viju will talk about a little bit more in detail, which actually sort of broadened the scope of the entire EV design course itself. Yes, Viju.
Sure, thanks. And just as Zahida speaking, iteration of this workshop is happening in Hyderabad at the moment with around 51 faculty focusing on the umbrella university or the state university called Jawaharlal Nehru Technological University, JNTU Hyderabad. So we're doing this so that around 30 colleges in the Hyderabad region could take it forward. So this is one thing. So the course overview, if you notice, the way we are put in is, how professors like it. What are the specific learning outcomes? What are certain things? So you can't introduce a modeling and simulation component without talking to the academics in their academic language or the pedagogical approach. So we've done that. So in a way, you do have the thing. But the minor that Zahida spoke about is this. So this is roughly 18 credits, so which means 4 or 5 courses and 1 capstone project typically. I don't want to get into too much of what the background is, but I would just get into the detail. Let me just zoom in a little bit so that, yeah. So essentially, the approach that we may take if this is approved is there'd be model-based systems engineering course, and then there's going to be an automotive electronics and diagnostics, and then the EV systems engineering course that you spoke about. And I think functional safety is very important in automotive systems. There's a lab and there's a challenge project. Yeah. So different entities have different requirements in terms of whether it should be 4 courses, 5 courses or something, so we can modify it as needed. Yeah. But each of these will have, if you notice, I'm just going to go through what does it do? In NEP, what does it sort of conform to? We actually have put in, whether it conforms to a particular a thing that's mentioned in NEP and all that. And each of these courses in the minor has what the course objective is and what the content should be. And as always, they want references, books or something, but it's possible that, this is important. Currently, there's not enough textbooks being written. So we may need to, just point them to, constantly updated thing. Okay. On that note, I also want to mention that in COSE, I'm sure a lot of you are familiar with it. It's the International Council on Systems Engineering, and they are taking an active role in introducing minors. They're actually introducing a minor in systems engineering in DIT, Defense Institute of Advanced Technology, because both aerospace and automotive have this as a focus as such, and we are partnering with them. We are on their advisory team as well. So in a way, this is something that we have experience with, and we are continuing to work either with AICT or individual institutions And this is something that we can explore doing as a group here, given that, we're all aligned in the same direction. So yeah, Zahida, anything you want to add?
Also, additionally, I'd like to point out that this was actually peer reviewed by a few professors and also by a few industry experts from the automotive industry that we work very closely with. So this is actually some sort of a validation that we have received from the ecosystem partners.
So yeah, cool. I will stop sharing, and that probably ends what I wanted to share for both questions. Thanks for the opportunity.
Sure. I think all excellent inputs. I have been taking notes of that. But it's good to see that there is already a structured, some form of solution or some form of thing that exists, which kind of jumped a little bit in terms of how it would look like. But would like to hear from other panelists also in terms of how do you see these courses or these skilling initiatives shaping up. Of course, one way is Arindam initiated the discussion, and we have had this, that there is a structured and credit based approach where it is more acceptable to the students. Academia also knows how to do those. But anything else that you would like to contribute or comment upon? For example, these are still being looked upon as additional courses or complementing courses. But what I have experienced doing my master's is these were prerequisites to do, a battery modeling course or a power electronics course. You need to know, MATLAB Simulink or PSEM and these things. And if you did not know, you had to do those and then come into this course. So could this thing also be thought about in our academics? Just a trigger to thought. So I would like to hear from all panelists in whichever order you would like to go. Supreet, yeah, please go ahead.
Thank you. There are a lot of inputs which I was listening to, but ultimately we have to understand something like unless all the stakeholders are engaged to drive this change, it is going to be very difficult for one set of stakeholders, like either it is industry or academia or otherwise government. What Arindam ji was referring to is that they have tried to bring in that as a integrated system, a kind of package which can go and translate what industry need and make them equipped with the right strength, and then they go and they join the industry. And what as an industry MathWorks is doing, because they have the technology available, so they are offering to many OEMs and other industries, they are also trying to bring in the right course. But how I look at it, Vikrantji, I see that, unless there is a strong interest of government and the government machinery, which is actually looking at integration and making it more and more modular, you have to look at something from industry perspective and learners perspective. So learners perspective is they are seeking a career in industry, and industry perspective is they want to solve their problem. Unless that integration happen at full, the challenge will stay. How do I look at it? Like there's a university system and diplomas and degrees are being published and people try to pick, but still there's lack of awareness in what industry need. And that can only be filled when industry is there in university system. And they are there in the form of center of excellences, they are in the form of programs, they are in the form of awareness, they are in the form of FDPs, internships. If there is a lot of availability of industry within university ecosystem and student is given a chance to listen to all those campaigns and then decide in a very modular way where they wanted to route their career to, and for that they are given about a 1 year of period within their university program where they pick and place all the subjects which they want to read. Unless that kind of system come in place, we will keep on juggling behind that, whether we should put one type of effort or second type of effort. I think the void which we wanted to reduce here is making learner aware about what industry need and where the career is available. I recently did a internship program for a Himachal-based university where I trained about 100 engineers. And these engineers, basically, we try to bring into artificial intelligence and how it is being applied in industry by giving them some real-time problem and seeing how they can emerge as a solver. Now, we were having about 1.5 month of period where we tried to first train them on the tool, then start breaking the problem into smaller pieces. And then we could see that we were able to nurture about 42 engineers who were able to bring some value to the kind of problem they had. I think with all this effort, which is parallelly going on, but where I find the entire system fail is that all the stakeholders are not part of this game. Like we go as a separate entity, and then we have to make them aware what exactly will help you. And then this goes to learner and to academia as well. And then there are a lot of compliances and structure systems in academia which do not let them move very flexible. I think from that angle also, we have to see that how much opportunity we have within academia for industry so that they can bring the right stuff to the learner. And once that kind of information is available to the learner, I think we will start getting right people, right resources who are either innovators or who have the right skill to function within the industry. And that is where, as a country, we will see a change within ourselves, because when we name other countries, we see that this change has already happened with some of them, where we quote example of Germany, Japan, where they have tried to integrate industry into academia. They have brought the entire universe within the university system. I think from that angle, when skill council like SPVs are there who are driving from their side to bring the ecosystem together, there is the larger bridge which we can reduce that gap and then bring everyone together. I think that is an effort we all have to make.
Absolutely. Thanks, Supritji. About we have to be also grounded in the practicalities. So really good point. Vinay Pratapji, if I could come to you as well, since you said you are representing academia. Of course, there are others who have worked in a dual role as well, but would like to hear from you what has been the conversation till now. Putting equal onus, I would say, on academia as well as industry. But your thoughts, please. Professor Singh, you are there. Professor Singh, if you are speaking, you are on mute. Vinay Pratapji? Okay, he might have stepped out. Ravindraji, you are here.
Doctor has left us because he has some lectures to take.
Okay. Sure. Ravindraji, you have your hands up. You wanted to add?
Yeah, I was hearing nice points are coming. 3 points I would like to highlight. One is that when you talk about the Center of Excellence Lab in a university, right? What is observed not only one college, widely in the colleges, it is not being fully utilized. Investment goes is unutilized, right? Because other colleges, etc., not common. Because if you physical invest, this has to be widely utilized. So this is one. So we need to always think about that how cloud-based these digital technologies can be adopted. So anybody from anywhere can access. This is one point. Second point, what we see that we wanted the students to learn this, etc., learn it, that the challenges which I have seen and while talking to them is that management of the university and college needs to be equally aware. You need to be equally aware and educated. That this technology is needed by the industry. They need to adopt it. If they are not convinced, it will not go down. It will not go down. That means it will not be adopted. So what awareness, education needs to be done by the solid, passionate industry mentor to them. One. Second point is that faculty needs to be equally trained. All this technology, there needs to become an ambassador within the institute. If they are not passionate, if they are not trained, if they are not done some kind of project, they cannot take it down to the student. Then come the student. And so this entire ecosystem needs to be built. Third point, whoever from the industry is coming, we can say that is widely experienced. If he doesn't have internally very passionate, come and explain, educate, motivate the people, he will not excite the student to and the management to get get adopted this technology. So these are the very, very basic fundamental critical challenges which needs to be addressed with them.
Yeah. Thanks. Thanks, Ravindraji. I would particularly pick on the first point and probably go to Viju or Zahida we have heard a few times in terms of having the COE, which is cloud-based, rather than replicating it in every college and university. How feasible this is, and how practical it is as well. I mean, feasibility might be there because cloud-based apps are there, but how practical it is to actually use that. On one hand, we say that yes, it will reduce the node resource requirement from where the students are accessing. They do not need to have 8 GB, 10 GB RAM machines, 12 GB RAM machines, but at the same time, how feasible it is in terms of internet bandwidth. These systems, or we work on that rather than replicating lot of hardware resources in every uh, uh, institute. Your thoughts on this, Viju or Zaida? Anyone of you?
Sure. So I think, meaning I'll definitely need to think a little more on this, but from if I were to ask, what is the concept of a COE that you have in mind as such? Because COEs come in various different forms and sizes. So what do you mean by a COE here? Based on that, Zahida, and I can definitely mention.
Sure. So COE would have multiple aspects. One of those is the hardware or the lab. And when we talk in terms of virtual simulation-based development, those are two things. One is, of course, the software, but other is the hardware, which is required to support those kind of simulations. We were using high-performance computing cores, doing multi-threading and all that for complex simulations, dynamic simulations. But how feasible it is to actually do the computing part and the software part on a cloud, and only submitting or formulating the problem and working on post processing the results on a local machine.
Sure. Okay. So one thing I'd say is I think most of the students have better laptops than us. Most of them are gamers and have GPU laptops and stuff. I don't think they need the cloud infrastructure, but jokes apart, but that's the reality. I take my laptop and I see the students have much better laptop as such. But see, from a cloud-based perspective, the learning aspect is quite straightforward, right? Meaning there are mechanisms in the form of, say, either the MOOCs, or even we have our own learning platform. There are these learning management systems, everything that, integrated many other things, including software tools, right? So that's one aspect from a learning aspect of things. The cloud-based thing is fairly straightforward to set up, right? And it can be, centrally hosted at some place as such from a learning perspective. But when it comes to an implementation standpoint and maybe you leveraging an external hardware entity to perform simulations, I do not believe we are looking at that complex problem in terms of simulation, because we are looking at design and simulation of, batteries, control systems, thermal modeling and stuff. Of course, it does get complex over time, but yeah, I don't know. I'll have to think about it. I do not want to give an answer that's irrelevant or something. But Zahida, if you may want to add anything that you feel is appropriate.
Yeah, so in addition to the learning, I think access capability is already there. And I think when it comes to the internet bandwidth, I believe that, there's sufficient, accessibility that is possible right now, because many software companies have moved to the SaaS model, and accessibility is not so much of an issue. But when it comes to the hardware, there are some evolution with respect to virtual labs, because not really having the physical hardware, but also looking at having hardware equivalent actually as a for digital model that can actually be used. So there is an evolving concept around virtual labs. There have been few companies that have been offering these kind of products and solutions that could also be leveraged for this particular platform. But from otherwise, I think there's a good amount of digital transformation that has taken place in terms of accessibility to some of these software and resources.
Sure. Thank you. Thank you for those inputs. And yeah, as we continue to evolve, and I am seeing more and more of at least system level things being enabled through these applications. Maybe the heavier ones will follow a little later. Supreetji, you have your hands up.
Yeah,
Please.
I would like to add one point here. When we look at cloud infrastructure and we are considering them for a COE setup, I think the major challenge which I see lies into many universities and institutions. I think the asset, that mindset that we should have an asset in hand is still prevailing in the ecosystem of academia. When we look at cloud infrastructure, it comes with a limited time span. Like the more you spend, the longer it stays with you, right? And then you have to also look at what is the kind of ROI you are generating. So here the ROI is basically learning, and it is not limited to any one problem or any scope of research. It is going like you are giving that access to many students, and then they are going to do a lot of stuff on that, and it is for a limited period of time. I think when we see from the institution point of view, they look at hardware in a form of asset. They say it stays with me. Even if it stays with me for next 10 years or 15 years, I can churn out some ROI from them. That's a kind of mindset they have. And when it comes to computing, there are infrastructures available in cloud where you can do a lot of computing. And for every computing you do, you are paying a cost. I think in the present arrangement, there is no system which we could evolve to, which is very cost effective, and also it comes as a package to the institution, and then they can be used both for learning and innovation perspective. I think when we see the cloud infrastructure, there are still limitations, and I have personally seen that they are more happy buying i7 with RAMs than going for cloud, because I think from this competency point of view also, they see that their people can manage that well, and they still don't have the capability to manage cloud and control the data, right? So there are a lot of challenges which are in that, and over a period of time this will get evolved and you will see that adoption happening. But personally, what I have experienced is, I think presently the interest lies on having assets and using it with the minimum bandwidth or internet connectivity.
Understood. Yeah. So by and large, it could be an option if they are able to put confidence as well as able to support cloud-based. They can do, and it could even be a combination of two.
Interestingly, you will see that a lot of opportunities by Government of India also, when they ask you to set up a COE, they are more capex oriented and asset oriented. You will hardly find funding being given to SaaS-based projects. I think those gray areas also have a lot of role in this. And when it comes to most of the digitalization companies like MathWorks and many others who are operating, so everyone has gone to LaaS or SaaS-based system, looking at industry keenness to adopt for that. But when it comes to academia, I think there is a time to go, and it will happen. But the road is still longer than expected.
Sure. Understand. Nagendraji, you have your hands up as well.
Yes, thank you for such a summarizing the points. A lot of points you have summarized together. Thank you, Vikrantji and Mr. Palji. But the point is, like, when it comes to digital India, actually, when we look for only the speed of the things, speed of the internet, or like, but when it comes to computing and cloud computing, we need better reserves of servers and those actually to accommodate such bigger computing we have. But when we look for open sources these days, open sources softwares, open sources like Python and GitHubs are coming up. Actually, they also helping the students to accommodate their more innovations with the available codes and available things on the internet, actually. But when we look into the perspective of scenario or any simulation, actually, the point is like when it comes to a student, he could try more anomalies, like when he has a kind of things to do with any project or anything he want to do. He must have an access to do the things which he could he could arrange some kind of scenarios, like together with some open source or some codes he could able to have, and he could run it on also on his computer PCs. Or so that's why when it not limited him to the cloud computing, but when we come across, he may get some open sources codes actually to make a scenarios of a automotive industry, some kind of problem solving he could do by himself on his PC. So in that perspective, some kind of problem statements could be available for him. The simpler codes could be available. So that also is needed to for a centralize the system actually. Like centralized system could able to also a foothold on the copying of the things also. And also when it comes to open sourcing the things, there will be a kind of innovation in there also. Like the student could access some innovation in the new technology, and he could utilize them to manufacture his scenarios and could able to make very good simulations by himself. That's why innovation comes from there actually. Student need some kind of secrecy and privacy in himself so that he could think about it and do some innovation rather doing everything on cloud. Maybe I could not say that the system is completely foolproof. Maybe his problem statement can be spread out in internet, or some other hacker could get away his concept. So he has to be given some kind of privacy and secrecy so that he could work from and bring out very good innovation. And that could be given to academia, that any hackathon he could utilize for playing his innovation. So hackathons are required there, like, because our indigenous technologies could not be like left over on internet, or any hacker could or any could be taken away from him. So like we have to preserve his copyright too. So in that perspective, open source codes are very important, and some open source softwares or any facilities are provided by the companies, center of excellences, so that he could able to innovate by himself some. So that's my point actually. Thank you.
Sure, Nagendraji. I would just follow up on because it seems like a good entry point to one of the points that we'd like to discuss as well, is what portion of this, or first of all, where do we start in undergrads and postgrad studies or working professionals? Where do we start this, and in what form? What could be brought in at undergrads level in terms of the skill? What could be brought in higher studies? And how do we now also address reskilling of professionals who would like to leverage this in their professional life? So would like to hear from Nitin ji, as well as Nagavendra ji, and then I would also go across the other members of the panel. So what do you feel is feasible to be taken up at what stage, and how do we build that structure? Nitin, you are still there? I think Nitin ji has left. So Nagavendra ji, if you could answer that, and then I will go across others as well.
Thank you, Vikrant ji. Actually, we have discussed a lot actually from the central government initiatives to the academia initiatives, the company initiatives. when it comes to a students, the Sukhpalji and the Vijuji and Ravindraji saying that the student is the main stakeholder actually, because he is going to perform in industry, and he the when in student perform, the whole country perform actually, because when he goes to an industry, he perform there, the company earns revenue, maybe he also earned some salaries, and he contribute to the society, and the companies could even invest in our country. But in a global acceptance, it's all about what the student or stakeholder getting from the whole academia or the system. So it's not about the student is facing so much problem in the system, but he is open to learn actually. So when it comes to a streamlining any course syllabus or a complete level of the courses he required to be get in an industry, the primary thing is that his undergraduate or maybe the diploma courses maybe. So diploma courses are very important these days, because when it comes to the skills, the industry needs the skills where he could be able to perform initially, like running a software, not a completely a full whole system he could build, because he could be put into small places where he could learn, and then he could grow his journey in the industry, so that he could be promoted or get an higher post actually, where he could be able to lead the company. Because many of the companies like in Japan, they are what I could say, training the individuals for the future ready, I could say future ready administrator. So from the beginning, they teach the student, and the complete I could say administration shares the experience and hold the journey together. Because what's I found that they are working in a family, they don't even change the companies, they stick to the single company whole life also. Like, I found that in India that's not the perspective these days, because many MNCs are coming, and they are their job change do, but but also the skills also is asked to them, that they just switch to the different company, what set of skills he's carrying, what kind of experience is he carrying to the industry, because maybe the European way of working, but many of the Japanese companies are not working that way. So the thing is that what kind of journey you are trying to make in a student. Is it he is the stakeholder, he is going to be a contributor, or he is the administrator, or he is the sole proprietary of the country also. Like, these are the things I need to imbibe or inculcate in the students, what type of student you are trying to make actually. Because if you are trying to make your country, like our country, India, to be a developed country by 2047, that's our dream actually. But with this kind of workforces which we are trying to build, is like we have to think about what kind of teachings we need to inculcate in the student. So in that perspective, if we are trying to build a syllabus, the journey should be like that. We have to create a system parallelly working with him actually. Otherwise, like, we will leave him somewhere in the market. So we have to be associate together longer actually. Academia or any industry together, we or the person who is been leveraged today maybe is the sole proprietary for the future also. So we have to be associate a longer time, or we have to be keep on exchanging the things together, because I don't think so. Like a alumni kind of thing, which we call it alma mater or alumni kind of thing, is to be strengthened from the beginning. So, like if ASDC is doing this thing for the students, they have to be keep on making a connection or alumni or sharing things all together, his life, what I could life journey or the career journey. So in that sense, the diploma person or any undergraduate or any postgraduate or anything, he could be able to access those courses, or maybe those courses could be able to leverage his uh, foothold in that company or any other company. So that foothold he requires these days to also perform, or to also to convince the companies that his skill sets are improving that day by day, and also he could lead a bigger team, or he could also bring the business to country or even the company. So like from the bottom level to the top level, he could grow, and not just because he's a good entrepreneur, become a good entrepreneur, or just a good administrator, because he is carrying a team. So that's kind of belief he has to be given from the beginning. So yeah, so we are not going to make only the a kind of student to achieve his dreams. We have to be achieving dreams for India, or for all together, for other coming generation too. So so those courses are like to be like with ethics, with also with mutual understanding, like business administration, but with cooperation and some logical based thinkings too. So in that case, like simulation based scenarios are need to be required in that case, because if some psychological things are to be included in that too, because if he could do all those psychological questionnaires together with courses, like what he could do with a team, what could he do with the things like simulations, a complete scenario, in that case, what kind of data he should share. Like if an example of like the AI Air India flight has been like crashed these days, along just in May or April. So the kind of data we have to share, or what kind of data scenarios, like in an accident, should be shared with the police or any kind of. So in such scenarios, like the kind of administrator do, or in a technical person do, is to be understood by the student too. So we are not just trying to make a simulation that he could just produce some simulation, or he could able to just do a simulation in industry and able to just yeah. So in such a way, we don't want to make a course syllabus. I'm just saying that way, but my main aim is not to make such a course. I am just trying to say that this course have an achievement is to have a program specific outcome, or program educational outcome, just academia uses that, but not just educational, but for a countryside also, country beneficial thing. So this should be come into existence also in courses. So yeah. So in that cases, I feel that diploma level, undergrad, postgrad, and like what we call it, a PhD level. But but in beyond that, there must be some administrative level courses should be inculcated in the yes. So that's only the point I actually but maybe I could go into more technicalities, but this is just my point. Thank you.
Sure. Thanks, Nagavendraji. And in fact, that brings me to Sukhpreet ji in terms of what is expected. So Nagavendraji talked about different phases, but what is expected, say, from engineering graduate getting into the industry at entry level, and we often also see that traditionally the simulation teams, they take postgraduates rather than graduates. Although I had the fortune of working as a graduate in simulation team, but by and large we saw that or are still seeing that. So what are the expectations and how they could be fulfilled irrespective of what level of study that person has done? If you could add that. Yeah.
Yeah, sure. See, if you think from how industry do not like those half-baked cakes. So that is where the answer goes. When they pick MTechs or they pick people who have some kind of experience doing simulation, the purpose is that they should do the job right. Now, when we have these programs introduced at graduation level or maybe a level below that, we could expect that some of them are really good engineers and they could address certain problems. Now, industry expectation is that they should have people who can solve certain problems. And as an engineer, what they are expecting is, so we have to look at in the layers in which industry works. So there are people who do the ground job, the execution job, then there are supervisors, then there are engineers. So it is all on decision making, how you make decisions and do things quickly, do things more productively. And then there are people who are into management. So when it comes to the expectation from engineers, especially simulation engineers or digital transformation engineers, the expectation is that they should know the tool well and they should be able to apply that tool to handle a real-time problem. And if they can do that within their academic journey, they are fit for industry to get adopted. We have seen a lot of people getting joined as a simulation engineer, irrespective of whether they have done BTech, MTech, or any other program. Now, also, you have to see where these programs can be introduced. Yeah, like we were addressing that, we can have it at diploma. I see, a huge opportunity because some of the state boards have already introduced AI as a program in STEM education. You have to look at the market size. You have to see how we are evolving in terms of learning and what is a new Gen Z and the next generation aspiring for. These technologies, which are so-called digital technologies, they can be introduced at different levels. Council being part of skill ecosystem, they are already doing a lot of level 1 to level 10 kind of programs. So level 1 can be introduced at a very fundamental level where you have the budding learner who is entering into some fundamental knowledge of technology. I think what we have to see is the readiness of that person before he enter industry. You will appreciate this fact that people who are doing 10th, you will find still most of them working in industry at certain level and doing certain level of technical job. Why they are doing, how they are skilled, we don't know. But after doing 10th, they have skipped their regular education and moved and joined some industry because of certain limitation. I think we should not do such an effort that we should only put technology to a certain premium level or a layer of education. We should rather make sure that when math is introduced, when creativity is introduced, when drawing is introduced, sketching can also be done, like CAD modeling can also be done. We can do one level of simulation also there. We can do virtual reality also there. We can teach them what artificial intelligence is. I think from that level, the evolution will start. And people who are exiting after 10th or exiting after 12th, at least they should not be deprived of technology. That is how I look at it. There's a huge opportunity of making people ready for tech, subjected to we have a right intent, and the boards also come forward and try and use these programs getting introduced at the very fundamental level. How I see to it is, if a graduate is exiting with the right skill set or diploma is exiting with the right skill set at a right level, he is employable. Subjected to industry has a problem for him. That is how I look at it.
Sure. And very good point, because we do see coding being introduced to students in schools. at even
Absolutely. See, I
primary
still remember I met a sixth class boy who was doing a lot of robotic stuff. Look at technologies like virtual reality, design thinking, system simulation, artificial intelligence, robotics. They are like gamification. If you give them at right level with right stuff, they are ready to play with it. And that brings a lot of logical reasoning in them. If we are teaching them 1+1 is 2, we can also teach them how this tool works in industry, right? But I'm not saying they are employable. I'm only saying if you introduce at the right level, maybe today, how many diploma holders India produce? Maybe about 10 or 15 lakhs. And then the similar equivalent is produced as engineers. But do you think that after doing a diploma, he has the right skill where he has to enter in industry and do the diploma stuff? Right. So if you can introduce little early and make them ready, industry is going to get bigger benefit of these people who are coming out.
Absolutely. Absolutely. Yeah. Nitinji, you are back, I think. So, would like to hear from you in terms of what competencies could be looked upon at what level, and how do we? It need not be just one single course or a curriculum, right? It could be distributed over multiple levels. So, what are your thoughts on that?
Yeah, so in my observations, like the simulation modeling is required a lot of fundamental understanding, and mathematics is always there. Otherwise, this is like a garbage in and garbage out, what we call in simulation world. So
Right.
India has tons of and lakhs of engineers, but we have to have this proper basic courses, basic physics wise courses, and then for example FEA, basic, and then intermediate, and then the advanced level of courses. Similarly for CFD, similarly for low frequency, which is electromagnetics, then we have something called high frequency, then we can call something called EMI/MC, then ADAS, and all those kind of different high tech, high product multi-physics simulations can be taught. But the basic criteria should be the passion of that person or the student, and a lot of these things can be introduced during their engineering, and it is that person's or that student's responsibility that he should put some extra effort and learn these skills during his 4 year of engineering. After 4 year of engineering, they are only thinking to get the job, but they don't have the right skill. So if you have the basic skills of these basic courses ready with them, with the maybe ASDC initiative, or Ministry of Education, or university, deemed universities, or the new education policy, and all of that, if you put all these things together, and plus industry is always there. Like I'm trying to help in this ecosystem from last 10 years. I see little bit of passion from the students and the faculty also, and that's where I know I'm not happy the way things are happening in India. There are a lot of these schemes, and government is ready to pump a lot of money, but these guys, the ecosystem is not advantages of this. So until is not going to happen. This requires passion and to make the contribution to the industry and to the country. So like we thought maybe will work, like let's start the ASDC chapter state wise, okay, or the city wise, and the way ASME works, all or the other ecosystem works, like SE India, right? They have the
Right.
chapters in every big cities or the state wise. Let's start
Right.
this because ASDC is like well known, and this is very specific to automotive. And I came from Pune, which is automotive world. This makes sense, and automotive is the industry which is driven. Every this industry is happening industry, and you can see a lot of opportunities. And India is
Right.
full of within 5 years will be the second most, or 10 years will be the second biggest manufacturer of the vehicles, basically the automotive segment. So this is the right combination which I see, and if we come together, this group take the ownership, I think nothing like that. I am ready to take the ownership for Maharashtra. I will make sure that we will have maybe 500 members, chapter mentor, and then the students within 1 year. This is my commitment to you. I will bring it to the table.
Great.
But something should be like this. Should we should take it and make it happen. That is what like my take.
Great. Yeah. So, I think in the interest of time, I would also move a little quicker. We are almost towards the end of the questions, and really good discussion, because it was not restricted to specific questions. So I've been noting down the points related to other questions as well. What I think we should talk about is, one is at what levels these courses would be, courses would be in terms of NSQF, and then what would be the quantum of learning in terms of hours. Now, in academics, it could be full time and it could be done in a lesser duration, but how much rigor, or how many credits, or how many hours of learning would be required to get started on this skill based course. So those points I would like to probably hear from Rabindra ji, and then move to Sukhpreet ji as well.
Thank you so much. Like for this courses, say for the diploma, degree, and the postgraduate and research, the courses will be different because the level of degree is made in such a way that they acquire certain skill, which meets the skill requirement the industry, right? So it will be always combination of engineering branches, engineering subject, and with the technology. And we can very well do it. We can very well do it. Absolutely no problem, right? We can do it. In fact, if we can make a kind of some group and we work towards together with that, and we can build it. That absolutely clear. We can make it.
Great. Sukhpreet ji, if you can come in terms of what NSQF level you envision, and of course the duration, as Rabindra ji said, it may vary, but in a sense, it could be a minor, or it could be a 3-4 credit course or something like that, which automatically defines the number of hours. Yeah.
Okay, so this is simulation. It is just an umbrella of many multiple different technologies which are now in place. Like we have digital twins, we have starting from CAD modeling, we have PLM, we have 1D simulation, we have multi-physics problem, and each technology or each solution for industry, for them the entry level has to be based on the kind of problem they are handling with the help of simulation, right? If I talk about modeling, there is something called sketching in modeling, very basic, very fundamental, which can be introduced at level 3, 3.5 to start with, just to make people do some sketching, a solid modeling. And then it can grow eventually, depending on the kind of interest learner is adapting to. And this can be very short fundamental program to introduce them to something like sketching. But when it comes to programs like digital twin or PLM, these are technologies where they need to have a bit fundamental knowledge of how things work in OT/IT integration and how basically the machines work. So these are technologies which have to be attended at like 4.5 above, like 5, because this is a kind of technology where you need to have some background of engineering. You must have read some level of maths, you must have read some level of core programs, and then you are exploring opportunities in PLM. So it has a different entry point altogether. So if I have to look at how the entry point has to be decided, I would rather say we have to break this entire thing into multiple opportunities within industry, and then start looking at entry point for each one of them. This goes with the saying, like technologies like VR and many other technologies, which also translate into some digital solutions like we did for some of the OEMs. I have seen people from non-engineering background entering into that, people with BBA or BCA or BA background, out of interest they are entering. So I do not want that the entry point for them should be like only tech program. It should be little below that. So I think for me, each job role has an entry point and opportunity, and we have to see that where we can infuse that job role based on the kind of opportunity as learner can create out of it, and then start looking at integrating them to the regular curriculum. That is how I sum it.
Great, great. So layered approach, there could be multiple entry points, and the job that is being mapped could essentially define the NSQF levels for them, and also the background or the prerequisites that for that particular layer is required. So those things could
Absolutely.
essentially
Absolutely.
define.
Thank you.
Sure. Thanks. Thank you. Coming towards kind of what duration of hours again will be defined based on what is the outcome uh, that is expected from that particular level of the course. But I think we are now kind of looking at. So, Arpit, I think I will sum up because in interest of time, we are already at 5. And some of the questions which are more specific in terms of what could be these courses called, we can address offline as well, because you'd get very specific inputs there. What I hear is definitely there is a need. There is a very obvious gap as well, where these courses would fit in to address those specific gaps. Looking at those gaps, if we design those curriculums, and again, not in isolation in terms of academics or even in terms of the disciplines. We have mechanical engineering, whether to host the EV course in mechanical or electrical. It's an electric vehicle, so but not getting into that, looking at strengthening more interdisciplinary initiatives, going across all streams of engineering within the academia, and then more importantly also looking at what specifically the industry needs at those particular job levels. There are certain jobs, or many jobs in fact in this, which can be filled with entry level engineers. So there is a direct job mapping that can be done. Project management or product line, those are higher jobs where typically we do not see people being recruited as freshers. But simulation work, there are many aspects which I see coming out of the discussion where entry level recruitments could be done, and it's the right skilling based on specific needs of the industry, which can enable that mapping. There again, industry academia collaboration in terms of having those very practical learnings is also very essential, because having a course and doing fictitious case studies or projects or mini projects will not actually help industry. If and we are all aware industry has a lot of those problems or those things to be tried out, which can be shared with the academia with a right level of data security provided. Then this can enable the academia to actually churn out people. Otherwise it becomes a chicken and egg. I have to learn everything on job, but I won't be recruited without those skills. That should not be the case henceforth. So looking at those opportunities, and then enabling, how do we enable whatever is required. In fact, simulation does require much less of infrastructure as compared to other aspects, I would say, of engineering or the job roles. But even in that, how do we leverage the technology, be it cloud-based, be it on in physical form, the hardware present in the institutions. How do we leverage that? It could be a hybrid solution where the reach is more important. We are able to reach more and more of learners. I'm not just restricting it to engineers, as Sukhpreet also said. How do we reach those people and give them the same quality of skilling and education that anyone else would have, plus it's also at par with the global levels, because unless and until that is ensured, the products that we want to bring in out of India on global stage, they would have the credibility. They would not have the chance to be considered. Forget about the performance and success of it. So I think those are the points which I quickly summarized. A detailed summary I will circulate after this. Arpit, as Nitinji suggested at the beginning, let us have a group form so that the conversation continues beyond 1:30 today. And I think we will have more inputs coming in beyond this meeting as well, and then we can go to the next steps. I think where the curriculum, the draft of the course outlines, and beyond that, the other steps could be followed. So, Arpit, I think that's where I would hand over to you if you want to add anything in terms of what the next steps are.
Thank you, sir. And thank you all the distinguished experts and participants who are present here. Thank you for your valuable time. And I would like to request Kiran sir to address and to give your points.
Well, because I think we already come to the end of the session and it's already almost 1:30, so I will not take much time. I just want to thank everyone for giving your inputs to this. As I said before, this is a emerging field, very important for future of mobility, and the experts who have contributed today have really given so much input that I think the job for ASDC is now cut out. So I'm sure that the team at ASDC will compile all the points received and create a framework for skilling people at different levels who can take the challenge of um, uh, simulation and digitalization. So once again, thank you very much, everyone. And thank you, Vikrant, for very ably managing this discourse. And I think we should all clap for you. And thank you, everyone, for joining and contributing.
Thank you, sir. Thank you, Deshmukh sir. Now I would like to invite our senior advisor, R.K. Sharma sir, to give your views and ideas.
Good afternoon, everybody. The time is very short, so I'll not take more than 1 or 2 minutes, So there have been many thoughts as the discussion was going on, and I think one of the best discussions that I have been part of. A lot of new learnings and a lot of new perspectives, frankly speaking, So I have 2-3 points which I would like the group to consider. One is that we should clearly identify the target segment, which needs to be, for which we need to address this challenge of, this subject of the talk today. It could be part of the college. It could be existing professionals. It could be non-engineering professionals who want to get involved with this. So that was one. So we should spend some time in figuring out what is the target segment. Number 2, where would it get done? Would it get done only in colleges or academic institutes? Would it be part of industry? If we call it training centers, come research centers, I mean, that's a thought which I have. And I think third, the biggest challenge would be preparing trainers or teachers to be able to discharge this duty. So I would not like it to get limited to certain types of people or industries. Let it be as broad-based as it might be possible, but address the immediate challenge as fast as we can. So that would be my request. And I think we have a fantastic group which can work to resolve whatever issues we think which we need to address. And thank you so much, and look forward to fantastic results from the efforts of this group. Thank you very much.
Thank you, Sharma sir, for highlighting these three points. And now, as we come to the conclusion, I would like to request ASDC CEO Arindam Jari sir to kindly deliver the formal thank you note and close the today's proceedings. Thank you once again, everyone.
No, thank you all the experts, and special thanks to you, Vikrant, for agreeing to anchor this discussion. Thank you, Deshmukh sir, for staying throughout the entire discussion connected. Raman sir, Prabhat ji, a lot of people otherwise also have been very connected. And I'm sure many of you will also subsequently have a few more points to contribute as we go along and try to do the implementation side of things in terms of what we want to impact. At ASDC, I think our endeavor is to largely look at what are some of those emerging areas, where are the gaps in the current academic and skilling scenario, and how can we structurally bring in programs which are more aligned to the existing structures, but in a new domain area, so that we get maximum impact out of that process. Thanks for sparing very valuable time. We will shortly share minutes of meeting of this, as well as the suggestion that we must form a special group for discussion on this, which Arpit and I will work together and make it work. Hopefully, we will be able to report back on some advances during the current financial year itself, where we are still left with about 6 months. So hopefully some of these could start getting into the action and implementation also. Thank you very much, and look forward to catching up all of you once again as we progress with this journey. Thank you.
Thank you.
Thank you. Thank you. Good day.
Thank you. Thank you.
Thank you. Thank you.
Thank you, everyone.
Thank you. Bye. Thanks.
Thank you.
Thank you.